Welcome. Oh, that's thumbs up. Sounds like you can hear us. That's awesome. So thanks for coming. Thanks for coming to our session about GitHub Copilot and Spring and making Copilot some kind of Spring aware. It's a bit weird experience with the silent disco. I need to get used to that, but that's okay. Cool. Thanks for coming. So my name is Martin. I work for Broadcom on the Spring engineering team. So part of these team that ships Spring Boot and Spring Framework. And I focus on the tooling, so we do these extensions for VSCode and Eclipse and stuff like that to make you more productive when you hack on Spring applications. And with me is Jinbo from Microsoft. He works from Shanghai. So he came a long way here, so that's really awesome. And we have a long history working together on VS Code extensions for in the Spring ecosystem. For example, if you know when you use VS Code, there's the Spring Initializer extension for VS Code and the Spring Boot Dashboard extension for VS Code. That's mostly done by the team from Jinbo, so that's awesome. So we have a long time collaborating on the different extensions for VS Code and also focusing on Springy stuff. That's why I'm super happy to be with Jinbo here today to talk about some new stuff that we are thinking about, some AI-related things we are diving into. And as kind of a heads up, it's a lot about work in progress. So it's not really presenting you final solutions and the answer to everything. And we are not trying to give you an answer like an LLM all the time. Sometimes we probably give up and say, oh, we don't know exactly how to do things in the future. But it's really our first steps that we share with you here, and I'm really looking forward to chat with you about that and hear your comments, your feedback, whatever. So it really would be really interesting. And with that, I hand it over to Jinbo to talk about the first section, which basically is about Copilot and what we do with these AI assistant things as a beginning. Right? Take it from here.
Yeah, thank you, Martin. So AI is now a very popular technology in the industry. So as a Java language tooling developer or as a Java user, we are always thinking, how can we leverage AI to improve our Java development experience in the IDE? So now I'm going to share a few use cases we can leverage AI in the IDE. As first, I will share the standard feature provided by the AI assistant like the GitHub Copilot. There is some other AI assistant provide the similar features. So the most famous feature in Copilot is code completion. So when you are writing code in the editor, the Copilot will predict what you wanted to do next based on the context in the cursor parts and generate the suggestion with the ghost text. So it's very intuitive for you to visualize the suggestions, accept it or skip it. The second powerful feature for code generation is generate the unit test. Writing unit test is a boring work for me at least. Now with the help of the AI, it can generate the unit test very carefully. It can save us energy. There's other helpful feature such as explain code in the editor or fix the errors in your code and generate docs when you interact with the coding in the IDE. The last feature is about the chart or inline chart. This is not only a feature, more like a platform. So if you know how to interact with the AI chart, you can do many things with the chart. Next, I'm going to share our suggestions how to navigate the chart to improve the Java refactorings. So as a Java language tooling maintainer, so we are keeping receiving feedback from the user to support more and more refactorings. Now with the AI chart, we think it enables the possibility to bring up more refactoring supports in the IDE. So the first refactoring scenario is suggest refactorings with AI chart. You can just use the prompt like the suggest refactoring for this Java file. So the AI will scan the whole file and generate the plans you can optimize your Java code. So this is very convenient compared to the traditional development mode. So in the traditionally, it's the developer yourself. You must to recognize what kind of refactorings you can apply to your code. Now with AI can teach you where you can optimize your code. So this is a very useful feature. The second scenario is to leverage the AI chat to refactor code in a specific pattern. So AI is very good at performing a very defined task. You can do something like the convert string concatenations in different approaches, or escape streams, dedupe repeated code, extract your code to these patterns, or extract long method to smaller ones. So all you have to do is just select the code snippet you want to optimize and type some prompt like the replace string builder with text block. So the AI will generate the change inside the editor. So it's very natural to visualize what the change you can do with your code. The third scenario is about the code migration, such as modernize your legacy code with the new Java standard or migrate code between different frameworks. Take an example for modernize legacy code. Nowadays, the JDK is evolving faster and more syntax sugar is invented. So you can use the new syntax to simplify your code. So all you have to do is to type some prompt in the code and use the prompt like the modernized Java code with Java 17, for example. So the AI will scan all the code in the current file and find out all the legacy code you can use new Java syntax to simplify. So this is also very helpful. So that's some Java refactoring scenarios. You can leverage AI chat to improve your Java development experience. Now we can compare the traditional IDE refactorings and the AI-based refactorings. So in the traditional IDE refactorings, so all refactorings are rule-based and predefined in the IDE. The feature set is hard to scale, so it's limited by the IDE. So usually, in the old way, if you want to support a new refactorings, you must write lots of code to analyze the AST tree and generate the text editor. So it's very hard to support a new refactorings. And also it requires the developer yourself to understand what kind of use case the refactoring can support and when and how to use it. Now with the AI refactorings, since it's trained based on huge amount of examples, that means the feature set is very easy to scale. And it's also more creative and handle more complex refactoring patterns. And also it can sometimes suggest refactorings you never used before or never considered before. Lastly, it's much cheaper to add new refactorings based on the AI chart. All you need to do is to write some prompt to enable new refactorings. So we think AI chart brings a big potential to enable more refactoring case in the IDE. Yeah, that's all my sharing about how to leverage the AI chart to improve the Java development experience. Now I'm going to hand over the sharing to Martin to talk about how to influence the AI assistant, make it to be Spring aware.
Yeah, thanks for these introductory thoughts about Copilot. As you can see, I think you can do a lot of great stuff with Copilot and with LLMs in general. And even though the talk is titled with Copilot, many of the thoughts are really not really super tied to Copilot specifically. They're really applied to any LLM or any AI assistant for dev tooling that you might be using or that you want to use or that you look at. Right? So the interesting thing is if you use all these kind of great examples of all the awesome stuff that you can do with these AI assistants, if you really use them in practice, for example, for a Spring project, you sometimes stumble upon these situations where you create a unit test, but the unit test does not really look like a Spring unit test. It more looks like a generic unit test that does not really fit into your project or fit to the functionality of the class, but not really to the annotations of Spring apps that it should have and things like that. So from the Spring tooling perspective, since we always think about how can we make Spring app developers more productive, we of course also think about how can we make the AI-assisted coding experience better if you hack on Spring Boot applications, right? So how can we influence basically the AI assistant? What ways are there to make it spit out better suggestions, better code completions, better answers that fit better your project, because we know this is a Spring project and we have a lot of knowledge about Springy projects. So the overall mechanics that you can use to influence large language models is basically, there are basically two different categories for that, right? One is you take the model and you fine-tune the model itself. So basically you apply new training data and you feed new training data into that, and there are different techniques how to do that actually, instead of kind of training a whole new model, just to fine-tune an existing one with additional training data, and you can do that, right? And after that, you usually have to run the model yourself, basically, because you have your fine-tuned thing. Only if you run a hosted service like Copilot, or like running against the OpenAI APIs or whatever, you cannot really upload your fine-tuning thing to it, right? Your fine-tuned model, right? You use the existing model. So this option is, for many cases, not really ideal, and it requires a lot of training data. It requires a lot of running the model itself and things like that. So it's it may be suitable for some situations, but not for others. On the other side, there's basically the option to influence and modify the stuff that you feed into the model when you ask it something, right? When you ask it for a code completion. And there are a lot of kind of different techniques for that, like the retrieval augmented generation, like you add more context to it, you define the prompt in a specific way. I'm sure you have seen these kind of prompts that are crafted in a specific way when you went to other talks at this conference or at other conferences, where people basically carefully craft the prompt or the stuff that they put in to the little window when they ask something to the LLM. So that's kind of the other option. And we, since we would like to kind of be flexible about the models that people use, we tend to look at the right side of this slide, right? Think about how can we modify and improve the experience using those AI assistant models when we cannot influence the model itself because it's running somewhere else. So how does it look like in the Copilot case, actually? Just as an example, right? So what do you typically can do, right? You type in your question, that generates under the hood a prompt. So Copilot is basically turning this into a prompt somehow, adding additional information. We don't know exactly what Copilot is doing. You can add additional context information to this prompt. Then you send the prompt to the large language model. You get the response back. You show the response, or usually you as a user, you interpret the response somehow. You evaluate whether it makes sense or not, whether it fits your needs or not. And then sometimes you kind of pick out code snippets from that, or you click a button that kind of tries to move the code snippets around, or you copy paste those code snippets, or those being kind of suggested for you in place, and you can press accept. Or you kind of go back basically to the first step of redefining the prompt, adding more information, saying, oh, this is not exactly what I asked for, or can you include this, or can you take this and that into account, and then it basically goes the same round again, right? So that's kind of the rough flow that Copilot uses, and that kind of many other AI assistant in IDEs do that as well. So how can we change this? How can we enhance this with our, let's say, Spring-specific knowledge that we have in mind? In Copilot itself, on VSCode, there are APIs for that, actually. There are already APIs, and these APIs allows you to either use the large language model directly yourself. So you can write an extension, and you can basically, instead of using the UIs that exist in VSCode for Copilot, like the chat window or the in-place chat, you can basically, under the hood, just submit queries, submit prompts to the LLM and receive a response and do whatever you want with that, right? So there's a direct API to basically submit prompts and receive the response back. And the other thing is, if you use the existing UIs for that, especially the chat UI, there's the option to inject an agent into that. And this agent is then basically capable of interfering with the stuff that you do with this chat window. So instead of the chat window talking to the large language model directly and displaying the result, as it would usually do, it can do something like, oh, it hands over the stuff to your agent can do something with it, and then you get stuff back. When we will see this basically in action. So the one thing that we can do here is, for example, we can predefine prompts and predefine questions for you, for the user, that we think makes sense for a Spring application and that we know might make sense for a Spring application developer. So instead of giving you the freedom of, hey, go and ask anything, we say, oh, these are probably questions or tasks or development tasks that people might want to do. Here's the predefined action for you, and behind the scenes, it is talking to the LLM. It is basically preparing the full question for you, so there's no need for the user to type something in because we prepared everything. Right? That's one option. The other option is when you use the agent in the chat, so you chat yourself with the agent, with the LLM, with Copilot Chat. Whatever you do, we enhance the prompt. So behind the scenes, we add additional information to the prompt that is being sent to the LLM in the end. So we add additional information. Whatever this information is, we will take a look at in a moment. Stuff is sent to the LLM, the response prompt comes back, and the agent is now being able to, let's say, do something with the response before it gets displayed to the user. So you can interfere with that. You could display something totally different, right? You can say, that's a funny response, I display something else. Or you can modify it, you can enhance it, you can basically do whatever you want. Interestingly, you can also do funny things like insert buttons so that the user is able to click on buttons in the response to execute certain actions that you think make sense if you look at the response. Interesting question how to do that and when to do that when you get a response back from a large language model. And then we can try to be smart about interpreting the response and knowing where to put the code, actually, which is really interesting. It's not so interesting maybe if you have these kind of in-place chat windows where you type something in place in the editor and you get kind of the suggestion for these 5 lines. That's, of course, you know, okay, this will be put into the editor at the position of the cursor. But if you go to the chat window and ask something like, hey, what do I need to do to upgrade my project to another Spring Boot version? What would happen if I would like to add a new dependency to my project and generate some sample code? What do I need to do if I would like to add persistence to my Spring project? Things like that. That affects multiple files, right? That goes across the POM files, Java source code files, application properties, and something else. Right? You get a huge response with all these code snippets. And we can be smart about that and basically know a little bit more precisely where to put the stuff and maybe make it easier for you to not just let you copy-paste all the code snippets yourself and try to find the right place, but just, for example, add something that puts the code into the right place because we know how a Spring project is structured, how a Spring project looks like. So let's make it Spring aware. The first thing is, this is something you can already use. And you might have already seen in another presentation, we do concrete actions. So we know in the Spring source code that there are specific bits and pieces, and we just started on that, where it might make sense to use a large language model to help you. For example, in Spring, you can use something like spell expressions, Spring expression language expressions. It's more or less like a different language to define these expressions, and it can put into annotations to calculate something, to check for a security role in Spring Security and stuff like that. It's pretty convenient way to kind of do these little computations for values inside of Spring apps when you configure something, for example. Widely used, but it's more like it looks like a different language, and not everybody is super familiar with that. So what we do is we insert a little action, say, explain this spell expression. Because Copilot, as a large language model, and the other large language models as well, they actually know everything about spell. Right? They know how to interpret spell expressions. They know how spell expressions are being built. and what all the elements are all about. So you can basically feed in a spell expression to the large language model and let it explain this spell expression to you and give you a nice summary of what is this spell expression actually doing. And the responses are quite good, especially since with our little action, it shows up everywhere in your code where you use a spell expression. There's a little code lens showing up automatically. You can click on it, and that kind of feeds the right prompt to the GitHub Copilot large language model, and it displays the result in the chat window saying, this spell expression is about bub, 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 and it is doing X, Y, Z. And in the detailed response, you see even stuff like, oh, this consists out of these elements, and they mean X, Y, Z. It's really kind of a nice way. We craft the prompt in a way that it gives you a nice summary, and then a more detailed explanation afterwards. So things like that. It's very concrete actions, very kind of something like a limited use of an LLM. It's not like, oh, it generates everything for you. You can go home and let it do all the work for you. But it's a very nice way to understand these bits and pieces that are not maybe your daily business, right, as a developer. Because you write Java code, maybe you're not an expert in Spring spell expressions. The same, for example, we do with query annotations for Spring Data. So you put in query annotations, and then you write SQL or JPQL or HQL or whatever, all these different dialects of SQL to query the database if you want to. So we have something like this as well, right? So we know in the source code, wherever there's a SQL expression coming up, because we know the annotations, we analyze that, so we have the access to that already in place. We know exactly, is this HQL, is this JPQL, so what dialect is it? So we craft a prompt behind the scenes, feed this to the large language model, and basically let it explain this SQL expression to you if you don't know exactly what the SQL expression is doing. I hope if you use Spring Data to implement your repository, you roughly have an idea about the SQL stuff. But in some cases, it might be useful to get a quick explanation or some details about those things, right? And we do the same for another language that we have in Spring, which is kind of AOP stuff and point cut expressions. So if you use AOP and point cut expressions about where something, how do you define exact point cut and execute it before advice or something like that. And these point cuts, they might look a little bit weird here and there if you're not familiar with them. You can also hit explain with Copilot, and it will give you a pretty good explanation because Copilot is trained on a lot of these point cut expressions already, so it knows how to interpret point cut expressions. So really nice. The second thing is about kind of filling in placeholders, but we haven't really digged into that too much, so that's why I leave it out here. And jump to point number 3. So don't wonder there's no slide for 2 here. And the 3 is the real full chat agent. And that's what kind of, we talked a little bit about these agents that can interact with these responses that are open-ended. And we try to make these open-ended questions a little bit better for you. So what we try is, if you go to the GitHub Copilot chat and you type in add Spring to tell the Copilot UI, please use the Spring agent here, so please do this. We feed in additional information into the prompt about stuff that we know from the project. Because we know, for example, this is a Spring project. We know which extensions or which modules, which Spring Starter modules this project uses. We know which version of Spring Boot is being used in here. We know what is important for a specific version of Spring Boot to take into account. So for example, hey, if you use Spring Boot 3, please generate stuff using Jakarta packages and not JavaXX packages, because the LLM does not really look into the whole project and can make up all these assumptions. If you ask it for, please generate a domain class, it will probably use JavaX packages most of the time because it was trained on this data all the time. And things like that. So what we do is, like, you say add Spring, and you say, for example, add JPA functionality to my project. So I would like to get some additional persistence into my project because I would like to use Spring Data. It will actually generate output that looks like a nice guide how to do this. And this is because we fed in this information. Please generate something that looks like a Spring guide for a regular Spring Boot project. And please take into account X, Y, Z, all these different things that we know about this project and Spring in general. And then it would tell you exactly, okay, these are the modules in your POM file. This is how the entity class, your domain object should look like. And please use Jakarta packages and not the other one because it's a project using Spring Boot 3. There's usually a repository. If you introduce a certain domain object and a service, maybe there's even a controller that you want to add for this new concept here. And a test case. And a test case for JPA in my Spring Boot app looks usually like this, something like that. And interestingly, that's a little additional smartness that we inject over there, at least where we try to be smart, is have an apply changes button at the end. So that you can easily press this button and the agent will interpret the response, basically pick out the elements of the source code and know where to inject this into your project structure. Because it knows the LLM says, oh, please add these 2 dependencies into my POM file. We know technically how to add dependencies to a POM file, right? So that's no magic. So we can just do it as long as we know which dependencies exactly to add to the POM file. That's what we get from the LLM, right? The exact content, basically, but how to add dependencies and where to put the dependencies into the POM file, we can just do it, right? And the same for all the other classes that are being generated, or for example, for properties that you need for your database access. So in some cases, the LLM also gives me information about, oh, you need these additional Spring Boot properties to configure your database connection. So we know these properties, they belong to an application.properties file. Or if you have an application.yaml file, we know that Spring Boot properties end up in this file in this way, so we can do it for you. You don't have to do it yourself, basically. But as I said, it's really just the beginning for us to really think about that and really experiment with that. So the Spring Boot agent that I showed you is not yet included in the release. It's more kind of a teaser or preview, exclusive preview just for you. The explain with is already there. You can use that. But there are a lot of challenges. And one of the challenges that we observed is that the large language model is changing all the time behind the scenes, right? So you can carefully craft the prompt now and try it 100 times and it all looks great. Next week, the large language model changed, and it will produce a different result. It does not look so good anymore, and your prompt seems to be slightly off. So you have to look at that again, which is kind of always a little bit challenging, especially if you try to make sure that you would like to control the experience for the user in the end, right? You would like to make sure that the result is great, that you can apply this change with a button, that you can do all these things, and that it always uses Jakarta packages or whatever. If the LLM always slightly changes behind the scenes, it's not really predictable, but that's kind of part of the nature of this technology, right? And then the other interesting challenge is new versions of stuff, right? So you know Spring Boot is coming up with a new version of Spring Boot all the time, sometimes minor versions, sometimes major versions, and that means usually that those changes should result in different code being generated. So if I ask the same question to a large language model for generate, for example, generate me this controller class for Spring Boot 2.7, it might look different than please generate this for Spring Boot version 3.4. But as soon as we ship Spring Boot 3.4, the large language model has probably never seen code written for Spring Boot 3.4. It has never seen that, right? Because it was trained on totally different data. It has never seen these new constructs. It's never seen these new versions, never seen the new APIs that are there. So we need to find a solution for that, and that's quite challenging. Because of course we can try to feed everything to the prompt and try to basically tell it exactly what the result should look like, but it's quite challenging to do that, and the prompts, you know, kind of limited in size. You cannot just feed the whole world into that, depending on which large language model to use. So that's an interesting challenge. It's the same with generating code for new language versions and things like that. A pretty interesting challenge because the large language model, the model itself, the training data, probably never contained data that looks like code for this language version or for this Spring Boot version. Pretty interesting challenge. Size limitations, I quickly mentioned that, these kind of how much context can you feed in. So I know that I think the Claude model is able to kind of, I don't know, with 1 million tokens or something like that, you can feed quite a lot of stuff into the context. But only adding stuff to the context does not guarantee you that the result will be better. Right? Sometimes stuff gets lost in the middle, right? And the LLM takes things at the beginning of the prompt into account, at the end, but not in the middle. The weird situations that can happen. So it's not a guarantee like, oh, add more stuff, add more stuff, add more stuff. The more I add, the better the result will be. So interesting additional challenge on top of the size limitations. And then there's the last interesting bit that we observed is we need to make sure that the response is really getting better and not worse. Because sometimes you can craft your prompt and then the result is getting worse than before. So why is it getting worse? And sometimes the LLM does not tell you why it's getting worse, or the LLM changes and then the response is getting worse. So you need to think about some kind of, and we start to think about that, some kind of automated testing mechanisms that we can basically run, like a test suite, we can run against a large language model and evaluate it, whether the responses with our specific prompts, with our specific modifications, really continuously create better results than before and move into the right direction, because just by trying it once or twice doesn't give you an exact result about is it really getting better or worse, right? Especially not if you just sit in front of you and say, oh yeah, today it looks better. Oh, tomorrow, I'm not sure anymore. Or I have a bad day and think, oh my God, this is all crap. So you really need some solid testing. There are testing frameworks and evaluation frameworks out there, but I'm not an expert on that. So we need to dive into that. And I think it's an important question how to kind of automate those testing. It's like these usual benchmarks that people run against large language models, like human eval or other things, where they evaluate how the coding responses from the large language models are. Are they good? Are they bad? Moving into the right direction? A whole interesting research topic on its own, I think. But it's quite interesting to think about that from a Springy perspective, because we try to make it better for you, right? So that's our goal. So we somehow would like to make sure that it's actually getting better and more efficient for you. And with that, I think we have not so much time for questions because we started a little late due to technical difficulties of the silent disco thing. But I hope it works, and I hope it worked. Perfect. Great. So thanks for that. Thanks for coming. Hope you enjoyed the presentation. And if you have any questions, I think we're still happy to answer a question. Or I have no idea how this technically works, right? So, oh, there's a mic in the back. So if someone has a question, otherwise, I think we are both here for the rest of the conference, basically. So please feel free to come to us, talk to us anytime. Happy to chat about every little detail and every other topic anytime. Cool.
Yeah.
Thank you.
Thank you.
Enjoy the rest of the conference.